things. So translation, scaling, reflection, rotation. For everything, the corresponding matrix representation would be x star y star in vertical fashion is equal to some xy, which is the old coordinate. This is the new coordinate. This is the old coordinate. Okay, and the dx dy is the corresponding transformation matrix. And similarly scaling also sx, sy, xy. So this and similarly here reflection also. All these things are related to. Let me use a pointer. All these things are the same equation, x star or p star. Simply you can write it like p star. P star is equal to plus or minus 1. This is the transformation matrix corresponding to reflection multiplied by old xy. Okay. And similarly this one also, for rotation also. Only this is the transformation matrix cos theta. But the calculation is of the same kind, which means p star is equal to this matrix multiplied by xy. So this I hope you can understand that all the transformation matrices in a single column so far, whatever that we discussed. But here I want you to understand one more, I want you to observe one more thing, that except translation, all the remaining three fundamental transformations are in a multiplication format, which means the old coordinate we are actually multiplying with a one transformation matrix. The transformation matrix may be different corresponding to different operations, but the form is always the same, multiplication form. We are always following the, here also you can simply use this matrix form, this transformation matrix multiplied with some old coordinate, so that you can get the new coordinate p star. But here also so three multiplication formats are there, whereas in case of translation it is not multiplication, but it is actually addition of two matrices. So in order to bring all these formats into one single format, which means into multiplication format. So everything you want to convert into a single format. That's what the requirement here to go for the homogeneous representation. Why do you need to go for a homogeneous representation? You will understand in the subsequent requirement for concatenation and all these things. Okay. So if you want to convert this operation, this addition also into multiplication format, then 2 by 2 matrices will not be sufficient in order to satisfy, in order to come to the homogeneous representation. 2 by 2 matrices or 2 by 1 matrices will not satisfy the requirement, and that is the reason people go for a 3 by 3 transformation matrices. Even though we are talking about 2D, try to understand, we are still talking about two-dimensional transformations only. Even for two-dimensional transformation, the transformation matrix would be, all the transformation matrices would be of 3 by 3 order. This is transformation matrix for translation. This is transformation matrix for scaling. This is transformation matrix for reflection. Similarly, this one is for rotation. All these transformation matrices are in a 3 by 3 matrices. Okay. This is the critical part that you need to observe and remember. Okay. This kind of representation, we are actually calling it as a homogeneous representation, where everything is a multiplication format. So for all the 4 transformations, we are actually we just need to remember the corresponding transformation matrix multiplied with the old coordinate. Now when you are going with the third order, then on top of xy you are actually adding simply you are adding a constant 1. So in each and every case, that will be xy1 only, xy1, here also xy1, xy1 like that. Okay. I hope you understand. And if you want to check how come these 3 by 3 matrices are same as the world, if you want to check it, no issue. If you try to multiply these two matrices, let us say you want to multiply these two matrices, which means this horizontal you want to multiply with, you need to multiply with this vertical. So 1 multiplied by x, this is the direction. Okay, 1 multiplied by x, x only. 0 multiplied by 0, dx multiplied by 1, dx. So altogether I am getting x plus dx. So x star is equal to x plus dx. So this is the same, right? X star is equal to x plus dx. Similarly, y star, if you try to multiply the second horizontal row with the vertical one, 0 multiplied by x, 0, 1 multiplied by 1, y, y, y plus dy. So y star is equal to y plus dy. The same thing. Only thing is, instead of additional format, I'm switching everything to the multiplication format. You don't need to worry about the third row at all. Why? Because it's simply it simply talks about the constant value. So it must be equal to 1. 1 is equal to 1. You will get it. 0 x. Okay. Here also 1 only. So 1. So 0 x, 0 y, 1 y, 1 into 1. So 1 is equal to 1. So it doesn't influence our actual coordinates. So no need to worry at all. The third, only for the sake of homogeneous representation, we are trying to make use of these constants. Nothing more than that. Okay. So I hope now I want every one of you to remember these transformation matrices. So once again, you look into all these transformation matrices. So now instead of this one, you must remember these things. You must remember all these things. These are the key. It's very important topic. So 1 0 dx 0 1 dy 0 0 1. So which means all diagonals are ones, whereas here I am getting dx dy. Remaining values are zeros. Okay, can you remember it? And now transformation matrix for scaling. Sx Sy. Diagonally you are getting Sx Sy, and there is no z. Sz you will learn in 3-dimensional transformation. Right now we are still in a 2-dimensional transformations. So you don't talk about Sz. So I am having only Sx, Sy. What do you mean by Sx and Sy? Scaling factor in x direction, scaling factor in y direction, which will be supplied to in the question. All these dx, dy, all these values would be supplied in the question itself. Okay, you don't need to worry. Even x, y, all the world coordinates also would be supplied in the question. Only thing that you need to do is you just need to multiply these matrices. For that, you should know this transformation matrix. So Sx, Sy diagonal, and third diagonal one is last diagonal one is 1. All the remaining values are zeros. Similarly, if you look at transformation matrix for reflection, plus or minus 1, plus or minus 1, this was the old format. Now in the homogeneous representation, this matrix would remain same. The matrix do remain same. Only thing is I am getting the third diagonal corner as 1, remaining all zeros. So you can understand that always the last bottom right is always 1. Bottom right is always 1. If you look at this, and all the remaining things, remaining values except the diagonal, all the remaining values are mostly 0, except for translation you are getting dx dy here in the third column. So similarly, rotation cos theta minus sin theta here. Same as this one, cos theta minus sin theta cos theta. All the 4 values I am getting at the beginning of the 3 by 3 matrix, and followed by the whatever that I said, the third one, bottom right one is always 1, and whereas the remaining things are zeros. So I hope you can remember all these transformation matrices, which are very important. Okay. Now the second topic is actually concatenation of transformation. Concatenation of transformations. What do you mean by concatenation of transformations? It's very simple, no need to worry. So far, we discussed about fundamental transformations. Try to understand. There is a difference between a concatenated transformation or a fundamental transformation. So far we discussed about fundamental transformation, which means all the operations are with respect to the coordinate system itself, with respect to the coordinates. But in reality, your requirement may be something different. For example, if you look at this particular picture, this is the original object. Let us say this is the original, this object. Sorry, this is represented P star, right? So, which means how can I erase this? I think you can. Okay. So, this is the original object. Okay, this is the original object, which is whose coordinates would be supplied to you in the question. You don't need to worry. And here the question is, there is a straight line. Arbitrary straight line, whose y-interception is c, and whose inclination with respect to x-axis theta. So, which means is that the straight line equation is a form y is equal to mx plus c, where slope m is equal to tan theta. Okay. So, the equation of this arbitrary straight line will also be given in the question itself, and they will ask you to find out the mirror image of the original object, this particular object with respect to an arbitrary straight line whose equations would be supplied in the question. Even in AutoCAD also, you would have already done mirror images, not only about x-axis or y-axis, but also about some arbitrary straight line. That's a very normal operation that people do, that people perform in most of the CAD models. But have we really learned about this operation so far? No. So far we know that mirror image is possible, and the corresponding transformation matrix is plus or minus 1, 0, 0, and that transformation matrix also we discussed. So, but what is that transformation what the transformation matrix can perform? It actually can perform mirror image about axis only, either about x-axis or about y-axis, but it is not dealing with a mirror image about any other straight line. Okay, though it may be a real requirement, still it is not discussed. So here what we need to do is, all these kind of operations, all these kind of advanced operations. Right now I am using the word advanced only to differentiate with the fundamental operations. So these advanced operations need to be divided into fundamental operations. Try to understand. Okay. So I hope the requirement is clear to you. There is an original object. This object you need to do the reflection. You need to get the reflection of this original object with respect to a arbitrary straight line, not with respect to x or y axis. So this is the requirement. So now, how can we divide this advanced operation into fundamental operations? This is the question. So what you have to do is, I know that the mirror image can be possible only with respect to x-axis. So this arbitrary straight line along with the original object, I have to make sure, I have to somehow move, I have to arrange, I have to do certain operations so that this straight line is exactly matching to x-axis. That is what I need to do. So in order to do, my next task is, if I simply, can I rotate? Simply because theta is there. If I rotate this straight line by minus minus theta, what will happen? The straight line, the straight line will be, if you extend like this, the straight line may intersect somewhere like this. So if I rotate this straight line by minus theta, then the straight line you may get it like this somewhere. It will not, if you rotate theta by minus theta, what will happen? Either if the point of rotation is this point, if the point of rotation for the straight line is this point, then if I rotate by minus theta, exactly the straight line matches to x-axis. But the rotation that we studied was not rotating about any other point. It is rotation about the origin. So the rotating center is different. So when the rotation center is different, the straight line after minus theta rotation will not match with x-axis. So what I have to do now? So now even rotate by simply minus by simply rotating also I am not able to match the straight line to x-axis. So next what I can do is, if I move, so further my thought process is going like, let us move the straight line by minus c. So if the y-interception is c, if I move the straight line by minus c, what will happen? The entire straight line exactly comes down by uh, c units. Why? Because it's a minus c I'm saying, right? So then the straight line will become like this. So the entire straight line. Only thing is the earlier straight line it was having some certain y interception, whereas the new straight line it is directly passing through the origin. As the straight line now it is moving through the origin. Now if you apply, the theta is still the same. That theta is still the same. What I did is I just applied the translation by minus c units. By doing that, the straight line, arbitrary straight line, now it is passing through the origin, and then if you rotate it by minus theta, then the straight line exactly matches to the x-axis. That is how I can bring the straight line matching to the x-axis. Okay, so my first transformation. So correspondingly, along with the straight line, all the original object, the straight line along with the original object, everything transform. Uh, uh, Whatever the operation that I told you, everything. So even this old object also do transform like this. Now the straight line is matching to the x-axis and the original object has moved to this location. Now if you perform the reflection I can perform the reflection of this object with respect to the x-axis, so that I can get the reflection like this. I can get the reflection image of this position like this. And once you get the reflection, then whatever the previous two operations that you performed, which means the theta in the clockwise you rotate by theta, right? Again you go back, you revert back to rotate the straight line which got matched with x-axis. Again you rotate it along with the reflection will be rotated, and then translate it back to minus c units, so that you can get the final reflection image of the original object. So that is how you have to divide some advanced operation or advanced transformation into fundamental transformation. So here how many fundamental transformations that I performed to complete this task are 5. What are those 5? I am going to explain all those things, don't worry. So T1 is the first transformation matrix. I also put this as a example question, so no need to worry about this. Right now you just try to understand. T1 is the first transformation matrix, T2 is the second transformation matrix corresponding to second operation, which means, what do you mean by T1? T1, the first T1 is by minus c unit. My minus c units, I just brought everything down by minus c units, right? The corresponding transformation matrix is T1. What is the operation? Translation. Movement, it is actually simply movement, right? Movement is nothing but a translation. So this is the T1 is the first transformation matrix for translation. What is the second one? The second operation that I performed, I rotated the straight line by minus theta. So T2 is the transformation matrix corresponding to rotation. What do you mean by T3? T3 is the transformation matrix corresponding to the reflection. Third one is the reflection. And fourth one is, again I rotated it back, and fifth one is a translation again by positive C units now. So after identifying all the fundamental transformation matrices, you have to multiply, right? The concatenation tells you about in which how you need to multiply all the transformation matrices. Okay, so always the first transformation matrix would be the rightmost one. Latest transformation matrix would be the leftmost one. It is not T1, T2, T3, T1 multiplied by T3. It's not like that. The first one would be at the rightmost. The second operation would be the, that would be added to the left. So on the left side, we are actually adding. So like that, the final transformation matrix for this particular operation, this particular problem is nothing but T5. It starts with the T5 because I'm having five fundamental transformation matrices. So T5 multiplied with T4, T3 like that. So this is how you have to, identify the final transformation matrix corresponding to any advanced operation, and this theory is called as concatenation of transformations to perform any advanced operation. I hope it is clear to you. Okay, now the same thing has been also discussed as an example. The problem is simple. Look at here. Determine the final transformation matrix to perform reflection of an image about an arbitrary straight line with y-interception c and angle of inclination with respect to axis theta. Of course, instead of c and theta, they may provide some values also. But here they are asking you to calculate only the final transformation matrix. They are not asking you to calculate the new coordinates, all those things. If they ask you to calculate new coordinates, first of all, they have to provide all the old coordinates also. So all the 5 old coordinates also, if they provide, then they can ask you to calculate the new coordinates after calculating the final. So in any way, I have to calculate the final transformation matrix. Then only that I can apply it on the coordinates if the question comes with the coordinates. Okay, so how do you perform this one? It's simple. As I told you, first the overall advanced operation is divided into 5 fundamental operations. First one is a translate the mirror line along the y-axis such that the line passes through the origin O. Okay, which means by minus c units I have to rotate, which means the here whatever is the mirror line, that mirror line, if you translate it by minus c units, okay, minus this is actually the dimension is c, but first of all, in order to bring this bring down, translate the mirror line by minus c, then the line will be a parallel line, which means the slope will not change. Only difference is now the line is actually passing through the origin. So this is the first transformation matrix. So dx, actually if you recollect, this is 1 0, here it is dx, 0 1 dy, 0 0 1. Okay, instead of dx it is 0. Why it is 0? The line is not translating in x direction at all. I am just bringing it down in y direction. I am not moving in an x direction at all. So x direction displacement 0, y direction displacement in minus c, right? So dy is equal to minus c. Now after that I have to rotate it, now my next operation is to rotate it so that the mirror line matches to the x-axis. So this is theta, right? So instead of theta, it is actually minus theta. Why? Because in our transformation matrix for rotation, the theta should be in a counterclockwise direction. But here we are rotating in a clockwise direction. We are actually trying to rotate in a clockwise. So theta will become minus theta. So the corresponding transformation matrix corresponding to the rotation is cos minus theta, sine minus sine theta, of course. So all thetas, if you replace with minus theta, this is how the transformation matrix will become. Similarly, mirror image about x-axis. The next operation that I need to perform is mirror image about x-axis. Whenever you want to do the mirror image about x-axis, y coordinate will become minus. So this is where you have to apply the minus. Whereas here it will be a positive. Okay. So positive here, minus here, negative. And the fourth one is rotation back. So the transformation matrix is like this, and translating back to the original mirror line. So this is T1, T2, T3, T4, T5. So the final transformation matrix is T is equal to T1 multiplied by T2, T3, T4, T5. So all these 3 by 3 matrices you need to multiply. Okay, don't worry, you no need to do all these things. The computer do perform. Okay, and now uh, for exams point of view, you will not be asked to calculate all these huge calculations. But for you to understand what is happening behind the screen, we took this as an example. Okay, so T1 is this one, T2, T3, T4, all the 5 matrices. First of all, they would be multiplied, and finally you will end up with the one final transformation matrix. So this is the transformation matrix which can perform reflection of an image, of a 2D image about any arbitrary straight line whose y interception is c and whose angle with respect to x-axis theta. So this, once you get the final transformation matrix, the remaining operation is same. What is the remaining operation? X star, or simply let me write it like a P star. P star is equal to this final transformation matrix T. This is the final transformation matrix T. T multiplied by all the old points, which means x, y, 1. If you have some in the present question itself, the original object is having 5 points, right? So here you will get with the x1, y1, and then x2, y2, x2, y2, y1, x3, y3, 1, x4, y4, 1. Here also, you know, all the corresponding new reflected coordinates, you get it as a final matrix. So this is a 3 by 3 matrix, this is a 3 by 3, and this is, if you have 5 coordinates, 3 by 5. This is a 3 by 5 matrix. This is, and whereas this is a 3 by 3 matrix. So multiplication of 3 by 3 to 3 by 5 will become 3 by 5 only. 3 by 5 only. So after multiplying whatever the coordinates that you are getting, all those coordinates are reflected image coordinates. Okay. So I hope it is clear to you. Now, if you look at one of the example, let us try to solve this problem. Then we can end this class. Okay. Now I want you to participate. You can switch on the mics. You can make use of the. Okay. Whoever wants to talk, they can raise hand. They can chat. Anything is fine. I hope the screen is visible to you. Go through the question. Go through the question and tell me how do you